So part 4 of this presentation discusses our plans for completing the project and kind of summarizes everything that you've seen up till this point. So if we took the goals for our project and put them into a short list, it would look something like this. The first part of this project was to create a data collection tool that was able to record the MAC address of any Wi-Fi signal that it came in contact with. Now, this tool would also need GPS capabilities so that it can tag that MAC address with a geolocation in the form of latitude and longitude. Additionally, this tool could collect other information such as altitude or anything else you might need. The next portion of this project would be to take the data that we've collected from that tool and insert it into a database. Finally, in order to integrate with that database, we need to create a server-side API able to be hosted on the OS class server on the Oregon State University campus, and that API will need to have an integration with native mobile apps. So as you've seen earlier in this presentation, the data collection tool is already fully implemented and we're in the process of collecting the data. This is just a screenshot to show you just part of what that tool is implemented in. This is the Java Eclipse Android ADK. So the next part of the process is to actually create the database. So right this week, Jimmy and Mayella are so this week we're still in the process of collecting our data points, but at some point we're going to be inserting them into a database, and this is something of what we have envisioned. This is just a simple relational data model, very simple, and what we envision it being implemented in right now is MySQL. Now we're not married to MySQL, it's just that's what we've done in the past classes. As you can see here, the MAC address can serve as the primary key, and then any other information can be referenced based on that key. So next up we have the server-side API. This is what's coming next. So the requirement for the server-side API is that it has to run on the OS class servers. Now that's the only requirement, and from that requirement we've now the next server-side API that will communicate with the database that we're in the process of building as we speak. The biggest requirement for this server-side API was that it had to run on the OS class servers. And with that in mind, I've written up a list of some of our options here. The first option is to create the server using a technology called Java Servlet. Now, the advantage here is that we've just recently worked with Java Servlets in one of our other classes, CS496, and most of us are somewhat familiar with this technology. Perhaps not to the level that we'll need it to be to build this API, but at least we know it a little bit. Of course, the deal breaker would be that we don't know yet if it'll run, or Java Servlets will actually run on the OS class servers. Another option we have is Python, and Python is well known for having a short and sweet syntax. It has also known for great data manipulation. Additionally, it has a really good framework for working with server APIs and creating server APIs called Twisted. Again, we don't know if this will work on OS class, so we're not sure yet if we can use this technology. Again, none of us have worked with this technology before, and it may turn out that the disadvantage of having to learn a completely new technology might outweigh the benefit of the shorter syntax and the framework, especially if we can't use the additional framework Twisted. So this is something we need to look into. Finally, C. We could implement the server in C. The advantage here is that we know that C works on the OS class servers. But the disadvantage is that in C, we really have no frameworks to work off of. As you know, there's not too many built-in libraries for C, and everything has to be built from the ground up. So this could be very time intensive. Now this is used to connect to the server-side API and to give the end users their real-time geoposition. The responsibilities of this application will be to retrieve and filter the Wi-Fi signals that it's receiving in real time, and it will filter them using a technique called the nearest neighbor fingerprinting algorithm. Again, that server-side API will feed back a latitude and longitude position, which optionally can be fed into the Google Maps API to populate a map view with the user's current location. These are just some mock-ups that we've made up to give us some In preparation for this portion of the project, we've made some mock-ups that will simulate what we envision this application looking like. As you can see, it has an intro screen here that gives the user some information about what this application will do, and then a list view and a map view. Finally, the last portion of the project will involve testing. As we're in week 6 now, I believe, end of week 6 actually, and we don't have a whole lot of time to implement the rest of this project. So this portion of the project, we've chosen to use something called user tests rather than write up many unit tests and integration tests for the project. So as you can see, this will probably involve a lot of walking around and comparing our positions on the phones that we have using GPS and other means versus using just our Wi-Fi signal itself. So that concludes part 4 of this presentation. Hopefully now you have a better idea of where we've been so far, where we currently are in the project, and where we're planning to go, as well as an idea of how we're planning to get there. Thank you.